So, hello everyone.
We are presenting.
I'm Diana Peace. I'm going to present the examples of inverse Laplace transforms. And our first example is the one you're seeing. It's take f of s. The function is 1 out of s plus 1. And find the inverse Laplace function. So first and foremost, as you're dealing with inverse Laplace transforms, you are going to put the table of inverse Laplace transforms at the back of your mind, the tables that we have seen in the earlier slides. You're going to have that table at the back of your mind. So with this example, let's kick off. Our function is 1 out of s plus 1. You are going to have to look at your question and then compare it with the expressions in the inverse Laplace tables. When you look at this question, you're going to look for an expression in the table that looks exactly like that expression you have, or that looks almost the same as the expression you have in your question. So when you look at 1 out of s plus 1, you see that the expression has an expression that it looks like in the table, which is 1 out of s minus 1. The only difference with the expression in the question is that the sign in the denominator is a positive, but the one that is in the table, the sign is a negative. So you're going to look for a way to simplify this question and make it look like the expression in the table so that you can solve it with ease. So the first thing you're going to do is to simplify, as I've said, and the only way to simplify this to make it look like the expression in the table is by introducing a negative. And when you introduce a negative, in the table it is 1 out of s minus lambda, or minus any constant of your choice. But now here, we are going to see that our lambda is a negative 1 after us simplifying, because it will become 1 out of s minus negative 1. We are doing this to make it look like the expression in the table so that we can solve it. So when you have 1 out of s minus 1, your Laplace inverse will give you exponential power lambda t. But now this time, after our simplification in the question, our lambda is negative 1. So you're going to just get your exponential power lambda t and replace the lambda with a negative 1. Then it will become exponential power negative 1 times t. And negative 1 times t gives us a negative. So our final answer is going to be exponential power negative t. I hope we are together on that. And then our second example is quite tricky, it's quite complex. I beg for some good attention here. So our second example is s squared. The function given is s squared plus s plus 1 out of s cubed plus 3. Find the inverse Laplace function. So to kick off on this, we are going to start by rewriting the expression as seen. And then at the back of your mind, as I told you, you are going to have the inverse Laplace table. So when you look at the expression you're given and look through your table that we discussed earlier in the earlier slides, you're going to find that there is no expression in the table that looks like the expression in your question. So the first thing you're going to do is to try and simplify, just as I told you in the first one. You're going to try and simplify the question and see if you can come up with an expression that looks like or is the same as an expression in the inverse Laplace table. So with that, you're going to find out that even after simplifying, we are going to simplify the denominator and make it, we are going to factorize out the s. The question had to be s squared plus s plus 1 out of s cubed plus s, such that when, pardon me on that, the question had to be s squared plus s plus 1 out of s cubed plus s. So s squared plus s plus 1, we are going to simplify the denominator by factorizing out s, and when we factorize out the s, it's going to be s into s squared plus 1. So when you see this, it can be solved as a partial fraction. So you're going to borrow your knowledge of partial fractions and bring it here. So you're going to assign letters according to the denominator. So our first letter will be A out of S. Why? Because S is independent. So it will just take the A for itself, A out of S. Then when you look at the next part of the denominator, it is S squared plus 1. This is a quadratic equation. But when you look at this quadratic equation, there is something not good with it. Okay, not good, but there is something with it. It does not have factors. It does not have definite factors. So in normal terms, it would be bx plus c, okay? But now since we are dealing with a function that has s, it's going to be bs plus c out of the denominator s squared plus 1. Then you're going to solve it normally as a normal partial fraction to become s squared plus s. The numerator will be equal to, you get the LCM of the denominator, this side of s squared plus 1, and then you keep dividing by the numerator, you're going to get what is on the side here, which is a into s squared plus 1 plus bs plus c plus into s. So you're going to start just as I told you, just as you've been doing partial fractions. So you're going to get figures and assign them to different parts of the question. So you will say when s is 1, a will be 1 when you calculate, a will be 1 when s is 1. When s is 2, you're going to get an expression which is 3 is equal to 2 plus b plus c. Then you're going to come and also substitute when s is 3, when s is 2, when s is 1, when s is 0, any figure of your choice. Then in the final step, you're going to find that a is 1, b is 0, and c is 1. Then from there, you are going to go back to your question. There's an error here, which is s squared plus s plus 1. You're going to rewrite your original question, which will be s squared plus s plus 1 out of s cubed plus s will now give us the expression that you have gotten from your partial fraction solving. So the Laplace inverse of now f of t will be given as, f of t was our original question, will be now given as the Laplace inverse. Don't forget these brackets as you write it, the Laplace inverse functions, the Laplace inverse of 1 out of s plus 1 out of s squared plus 1. Close your brackets. Then you're going to now look, when you look at this expression that you've gotten, the functions you have actually look like expressions in the inverse Laplace table. So we're going to look at 1 out of s, that is the inverse Laplace constant. Should I call it a rule? Yes. So 1 out of s is the Laplace inverse for a constant, right? So the constant is the one on top, 1 out of s. If it was a 6 out of s, then our answer would be 6. But since it is 1 out of s, that means this expression gives us a Laplace inverse of 1. Then plus, because plus is a sign that is joining them, the plus is 1 out of s squared plus 1 out of s squared plus 1. When you look at this, it looks like the Laplace inverse of a signed function. So in the table, it looks like beta out of s squared plus beta, or any other constant that you've used to study. So when you replace beta where it has to be, it's going to be 1 out of 1 sine 1t. Okay? But since 1 out of 1 is 1 and 1 times c is c, so you're going to end up with 1 plus sine t. And that will be the final answer. I hope this was helpful.